Good morning, everybody. I am Dr. S.S. Naidu, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss about a very important topic in probability and statistics. It is binomial distribution. As you are very much familiar with binomial distribution from 10th class onwards. What does it mean? Binomial distribution. How many terms are there in that? It is the distribution of binomial means two terms, some x and y, some x plus y to the power some n, or some x minus y to the power n. In whatever it may be, that binomial distribution in general is defined as some x plus y to the power n is equal to nc0 x power 1 plus nc1 x power n minus 1 into y plus nc2 x power n minus 2 into y square plus etc. Rth term, general term, ncr x power r into y power n minus r plus etc. ncn x vanishes, y to the power n will be there. So up to that, from 10th class onwards, we'll learn the basic of binomial distribution. Now we relate this whatever we learned in previous, that binomial distribution, to some random variables. Some especially this binomial distribution can be related to, can be linked to discrete random variable. So this binomial distribution is a type of distribution which will be hold good for discrete random variables. Previously, we have discussed about normal distribution. That normal distribution it holds for continuous random variable, whereas this binomial distribution holds for discrete random variable. So now let us see how this binomial distribution holds for a discrete random variable, and what is the general term, and how does it function, what is its distribution, how to find its probability density function, all these things, and how it will be their graph. In binomial, suppose in binomial distribution, if number of trials n is equal to 1, then it will become Bernoulli distribution. Bernoulli, that n is equal to 1 means it is a Bernoulli trial. It has only one Bernoulli trial. That entire distribution, binomial distribution, known as Bernoulli distribution. If n is equal to 1, number of trials is 1. It is Bernoulli distribution. Like that, this binomial distribution is a hold for a discrete random variable. So the binomial distribution formula, it is nothing but different, new. It is from the beginning, whatever we know, we have discussed at the start of this topic, it is only according to the situations, we just modify, it depends upon the conditions there exist. Here the binomial distribution is a commonly used discrete distribution in statistics. The normal distribution, as opposite to a binomial distribution, is a continuous distribution. So binomial distribution is defined for discrete random variables, whereas normal distribution is defined for continuous random variable. Now, the binomial distribution represents the probability for x successes of an experiment in n trials. Number of trials is n. Given a success probability p for each trial at the experiment. binomial distribution in statistics, we can discuss like this. The binomial distribution forms the base for the famous binomial test of statistical importance. Later, we will come to know the significance of this statistical importance. It gives 70% exact data with from an unknown variables. That is the significance of this statistical importance. For that, this is the base. So here X refers for number of successes, small p refers for success probability. So the failure probability is defined by Q, that Q is equal to 1 minus P. Here P is success probability, Q is failure probability. A test that has a single outcome, such as success or failure, is also called a Bernoulli trial or Bernoulli experiment, and a series of outcomes is called a Bernoulli process. Here what we have to recognize here, what we have to find here, in Bernoulli trial or Bernoulli process, only one thing will be there. It is either yes or no, success or failure. That's all. Only one thing. There is no second thing. It firmly cuts for one thing. Either it is true or false, success or failure, or whatever it may be. That is called Bernoulli trial. The process is called Bernoulli process. Consider an experiment where each time a question is asked for a yes or no with a series of n experiments. Then in the binomial probability distribution, the Boolean valued outcome. Previously you might have known about Boolean algebra. The entire Boolean algebra depends on only two elements, 0 and 1. 0, 1. With these two elements only, the entire Boolean algebra will be discussed there. These 0, 1 are called Boolean vectors. So, in the binomial probability distribution, the Boolean valued outcome, that is either success or failure. If it is fail, 0. If it has a success, 1. It is represented with a probability P, where P stands for success probability and Q stands for failure probability. That's why Q is equal to 1 minus P. In a single experiment, when n is equal to 1, the binomial distribution is called a Bernoulli distribution, I told you earlier. If number of trials is 1, that experiment is called Bernoulli experiment, Bernoulli trial, and that process is called Bernoulli process. Now let us see the standard formula for binomial distribution. Here whatever we are discussing here is not at all new, which we have learnt from our 10th class onwards. The binomial distribution formula is for any random variable x given by probability of x variable, n number of tries, p success probability, p of x and p is defined as it is equal to NCX. N stands for number of trials, combination of x number of successes of p to the power x, success probability to the power number of success into 1 minus p failure probability to the power n minus x number of trials minus number of successes. This is what we learned from 10th standard onwards. That's why it is also known as P of x and p is equal to ncx p to the power x q to the power the 1 instead of 1 minus p take x take q. Here p plus q is equal to 1. Therefore q is equal to 1 minus p. Here p is a success probability, q is a failure probability. So p of x and p is equal to ncx p to the power x into q to the power n minus x, where n is the number of experiments, number of trials, x is equal to number of successes 0, 1, 2, 3, 4, etc. Small p stands for probability of success in a single experiment. Small q is probability of failure in a single experiment. So q is equal to 1 minus p. The binomial distribution formula is also written in the form of n Bernoulli trials, where n Bernoulli trials we are talking means number of trials is equal to 1, n is equal to 1. Then the above formula will be abridged to ncx is equal to n factorial by x factorial into n minus x factorial. This combination formula came from that only, from our basic binomial distribution formula. That if that formula is taken for n is equal to 1, then our combination formula comes ncx is equal to n factorial by x factorial into n minus x factorial. So this combination formula came from fundamental binomial distribution formula. It is a special case of binomial distribution formula. What is that special case? Bernoulli experiment. Means number of trials is equal to 1. Then that formula is abridged to this ncx is equal to n factorial by x factorial into n minus x factorial. Hence, x and p is equal to p probability of x and p is equal to n factorial by x factorial into n minus x factorial into p to the power x into q to the power n minus x. Proceed for probability. Now, this binomial distribution formula, now we frame like this. Same what we discussed now, probability of x is equal to, that is the notation for ncx into p to the power x into q to the power n minus x. So instead of ncx, you write n factorial by x factorial into n minus x factorial into our terms p power x into q to the power n minus x. Here n stands for number of trials or the number being sampled. X stands for the number of successes desired. P stands for probability of getting a success in one trial. Q stands for 1 minus P. It is a failure probability in that trial. So, binomial distributions must also meet the following 3 criteria. The number of observations or trials is fixed here. So, in other words, we can only figure out the probability of something happening if you do it a certain number of times. This is common sense. If you toss a coin once, your probability of getting head is 50%, 1 by 2. Like that, getting toss 50%, 1 by 2. Your success probability is P is 1 by 2, failure probability Q is 1 by 2. If you toss a coin 20 times, your probability of getting a trials is very, very close to 100%. So, each observation or trial is independent. No trial is dependent on other. In other words, none of our trials have an effect on the probability of the next trial. The probability of success, tails, heads, failure, pass, is exactly the same from one trial to another. So, in Bernoulli trial, only one thing, yes or no, success or failure, only one thing. Now, there is nothing others. So, the probability of success, trials, heads, fail or pass is exactly the same from one trial to another. Once we know that our distribution is binomial, we can apply the binomial distribution formula to calculate the probability. So, we are going to discuss what is binomial distribution. The binomial distribution is closely related to the Bernoulli distribution. It is a special case of binomial distribution. According to Washington State University, if each Bernoulli trial is independent, automatically, clearly it is independent, then the number of successes in Bernoulli trials has a binomial distribution. On the other hand, the Bernoulli distribution is the binomial distribution with n is equal to 1. In a binomial distribution, if number of trials is 1, then automatically it averages to Bernoulli distribution. That process is Bernoulli process. A Bernoulli distribution is a set of Bernoulli trials. Each Bernoulli trial has one possible outcome chosen from yes, success or failure. In each trial, the probability of success P of S is equal to P is the same. The probability of failure is just 1 minus the probability of success. So, P of F is equal to 1 minus P. Remember that 1 is the total probability of an event occurring. Probability is always between 0 and 1. We know 0 less than or equal to P of E less than or equal to 1. And success probability plus failure probability is equal to 1. These things are very familiar with us. Finally, all Bernoulli trials are independent from each other, and the probability of success does not change from trial to trial. Even if you have information about the other trials outcomes. So, Bernoulli trial is defined for n is equal to 1. Now, mathematically let us define binomial distribution using our real life examples. Many instances of binomial distributions can be found in our real life. For example, if a new drug is introduced to cure a disease, it either cures the disease, it is successful, or it doesn't cure the disease, it is a failure. If you purchase a lottery ticket, you are either going to win money or you aren't. Basically, anything you can think of that can only be a success or a failure can be represented by a binomial distribution. Using the first binomial distribution formula, let us discuss some facts about this. The binomial distribution formula can calculate the probability of success for binomial distributions. Often you will be told to plug in the numbers to the formula and calculate. This is easy to say, but not so easy to do, unless you are very careful with the order of operations. You won't get the right answer. If you have a tie 83 or tie 89, the calculator can do much of the work for you. If not, here is how to break down the problem into simple steps so you get the answer right every time. So it is all depending on proper ordering. Let us see one example. A coin is tossed 10 times. What is the probability of getting exactly 6 heads? This is the question. By seeing that only, you should be able to analyze what is n, what is x, what is p. Here, what is n? Number of trials, how many are there? 10. Here, how many successes are there? Number of heads, 6 has to come. So, x is equal to 6. What is the probability of getting head? Clear, 1 by 2. What p? 1 by 2. What is the probability of failure? Q. 50%, 1 by 2. So after analyzing this, let us keep our binomial formula. Now our binomial formula is d of x and p is equal to, standard we know, NCR x power n minus r into y power r. Now from that we are taking x and p is equal to ncx into p to the power x into 1 minus p. 1 minus p stands for q to the power n minus x. The number of trials, n is 10 here. The odds of success, tossing a heads is 0.5 is 0.5 and like that. Failure probability also, q also 1 by 2. Now we have to find p of exactly 6. P of x is equal to 6 we have to find now. So use the formula. N is 10, x is 6, p is 1 by 2, q is 1 by 2. Place in them 10c 6, 1 by 2 to the power 6 into 1 by 2 to the power n minus p, and 10 minus 6, 4. After simplification, it comes 0.205078125. Now let us take one tip here. We can use combinations calculator to figure out the value for NCX. Now, how to work a binomial distribution formula? Let us discuss with the help of this example. 80% of people who purchase pet insurance are women. If 9 pet insurance owners are randomly selected, find the probability that exactly 6 are women. Let us do it step by step. In step 1, identify n from the problem. Using our example question, n, the number of randomly selected items is 9 here, 9 pet insurance, 9 here. So n is equal to 9. Come to step 2. Identify x, number of successes from the problem. Here, the number we are asked to find the probability for is 6. So x is equal to 6. Come to step 3. Work the first part of the formula. The first part of the formula is n factorial by x factorial into n minus x factorial. Calculate and keep it in our standard formula. Instead of p, keep 1 by 2. Instead of 1 minus p, keep 1 by 2 and simplify. So, like that, let us see some more examples on binomial distribution formula. If a coin is tossed 5 times using binomial distribution, find the probability of exactly 2 heads. And that means x is equal to 2. Means you have to find p of x is equal to 2. Next question what they are asking? At least 4 heads. At least 4 heads means there should be 4 heads and 5 heads also can come. Minimum 4. At least 4 heads means 4 heads can come. 5 heads also can come. Means here you have to take p of x is equal to 4 plus p of x is equal to 5. Here exactly 2 heads means here you have to find p of x is equal to 2. In second question, at least 4 heads. At least 4 heads means 5 heads also can come. That's why both you have to add. P of x is equal to 4 plus P of x is equal to 5. At least means more than that also can come. Now, let us see its solution. The repeated tossing of the coin is an example of a Bernoulli trial. Because every time they are doing, for every time n is equal to 1 only there. That's why it comes under Bernoulli trial. According to the problem, number of trials here n is equal to 5. Probability of head, we know p is equal to 1 by 2. Failure probability also q is equal to 1 by 2. For exactly 2 heads means x is equal to 2. Means what we have to find? P of x is equal to 2. Probability of x is equal to 2 we have to find now. Keep it in formula. NC2, NCR, NCX, 5C2, P to the power x 2 into q to the power n minus x, 5 minus 2. Simplify. 5C2 means 5 into 4 by 1 into 2. Is how much? 5 factorial. So, 5 factorial by 2 factorial into 3 factorial. It is, after simplification, it comes as 5 by 16. Now, let us come to second bit. For at least 4 heads means x is greater than or equal to 4. So, we have to find probability of x greater than or equal to 4. So, in this, 2 cases will come. P of x is equal to 4 plus P of x is equal to 5. At least 4 heads means 5 heads also may come. So, both you have to find and add. Hence, P of x is equal to 4 is equal to 5C4, P to the power 4, Q to the power 5 minus 4, it is 5 by 32. P of x is equal to 5 is 5C5, p to the power 5 into q to the power 5 minus 5. It is 1 by 2 to the power 5. It is 1 by 32. Add these two. So p of x greater than or equal to 4 is equal to 5 by 32 plus 1 by 32, 6 by 32. It is in simplest form 3 by 16. So let us see one more example. For the same question given above, find the probability of getting at most 2 heads. Here in probability some specific terminology is there. At least means that much should be there, more than that also will come. Exactly means up to that much only. At most means that is the most, and below that also will be there. Here p of getting at most 2. At most 2 means p of x less than or equal to 2. So here terminology we have to keep it in mind. Here at least means up to that, and more than that. Up to that and more than that. At least. Exactly means up to that. Next, utmost. Utmost. Up to that and below that. This is very, very important terminology. Keywords, terminology. We have to understand. Their meaning is like that. At least means up to that number and more than that also will come. Exactly means up to that number will come. Utmost means up to that and below that we have to take. Here they are asking of getting at most 2 heads. So p of x less than or equal to 2 we have to find now. It is p of x is equal to 1 plus p of x is equal to 2. P of x is equal to 1 we found there. It is 1 by 32. P of x is equal to 1 we found there. It is 5 by 32. Add them. It is 3 by 16. So what is the term given there, that should be clearly understood to us. Then we can practice in our sums. Let us see one more example. 60% of people who purchase sports cars are men. Find the probability that exactly 7 are men if 10 sports car owners are randomly selected. Here you try to pick out the values of n, x, p, q. Here n is number of persons. Here they are sports person, they are 10 here. Among them, here success persons exactly 7. So x is equal to 7. Here probability is 60%, means 0.6. Automatically failure probability is 1 minus 0.6, it is 0.4. Now all terms came here, keep in formula. We will find the answer. Now let us see some binomial distribution examples. As we already know, binomial distribution gives the possibility of a different set of outcomes In real life, the concept is used for finding the quantity of raw and used materials while making a product. Taking a survey of positive and negative reviews from the public for any specific product or place. By using the yes or no survey, we can check whether the number of persons views the particular channel or not. The number of votes collected by a candidate in an election is counted based on 0 or 1 probability. Now, let us distinguish binomial distribution and normal distribution. The main difference between the binomial distribution and the normal distribution is that binomial distribution is discrete, whereas the normal distribution is continuous. It means that the binomial distribution has a finite amount of events, whereas the normal distribution has an infinite number of events. In case if the sample size for the binomial distribution is very large, then the distribution curve for the binomial distribution is similar to the normal distribution curve. So, this is the noteworthy point. If the binomial distribution is very large, then the curve for the binomial distribution is similar to the normal distribution curve. Now let us discuss properties of binomial distribution. The properties of the binomial distribution are: there are two possible outcomes, true or false, success or failure, any one thing, yes or no. There is n number of independent trials or fixed number of n times repeated trials. The probability of success or failure remains the same for each trial. Only the number of success is calculated out of n independent trials. Every trial is an independent trial, which means the outcome of one trial does not affect the outcome of another trial. For a variable which is to be binomial random variable, all of the following conditions must be met. The first one is there are a fixed number of trials, a fixed sample size, n is limited. Second one, on each, that's why it comes under discrete random variable. Second one, on each trial, the event of interest either occurs or does not. Third one, the probability of occurrence or not is the same on each trial. Fourth one, trials are independent of one another. So, in this binomial distribution, we are discussing various facts and how it comes under, it obeys for, it holds for a discrete random variable, and here what is probability, success probability, what is a failure probability, and depending upon that, what is the special case of this binomial distribution? Bernoulli distribution. Bernoulli distribution, when does it come? When number of trials n is equal to 1. So, if n is equal to 1, that binomial distribution, it bridges to Bernoulli distribution, and that entire process is known as Bernoulli process. Yeah. In Bernoulli process, there are no more than one cases, only one thing, yes or no, success or failure, that's all. So, what is the main difference between binomial distribution and normal distribution? Binomial distribution has a finite number of events, whereas normal distribution has an infinite number of events. That's why if the binomial distribution is very large, then those curves also will be similar to one another. Then the distribution curve for the binomial distribution is similar to the normal distribution curve. So, once again, let us see the properties of binomial distribution. The properties of the binomial distribution are, there are two possible outcomes, true or false, success or failure, yes or no. So, for a variable to be a binomial random variable, all of the following conditions must be met. There are a fixed number of trials. On each trial, the event of interest either occurs or does not. The probability of occurrence or not is the same on each trial. Trials are independent of one another. So in this recapitulation, where we have discussed again all these things of binomial distribution, and we have elaborately discussed binomial distribution, and we have distinguished this binomial distribution with normal distribution. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.